Hey everyone, I'm Jay Chandra, and today we are going to learn a new topic on data structures, that is sparse matrix. First, let us know a little bit about matrices. Matrices play a very important role in solving many interesting problems in various scientific and engineering applications. It is therefore necessary for us to design efficient representation for matrices. Normally, matrices are represented in two-dimensional arrays. If in a matrix there are m rows and n columns, then it is called an m into n matrix, and the space required to store those elements will be m into n into s, where s is the number of bytes required by the data to store the value. Suppose there are 10 rows and 10 columns, and we have to store integer values, then the space complexity will be 10 into 10 into 2, where 2 is the space required by the integer, that equal to 200 bytes. And today our topic is sparse matrix. If in a matrix there are more zero elements than non-zero elements, then it is called a sparse matrix, which implies there is a lot of space getting wasted in our matrix. Sparse matrix, the time complexity, the Bigot notation of a sparse matrix is n square, because for searching any element we'll have to go through every row and every column to reach an element, which will require two nested loops, hence the n square. Example, if the matrix is of size 100 into 100 and only 10 elements are non-zero, then for accessing 10 elements, one has to make a 10,000 times loop, and also only 10 spaces will be with non-zero elements, and the remaining space of the matrix will be filled with zeros only, which will waste a lot of time, a lot of space. Representation of sparse matrix. Normally, sparse matrix is represented in a triplet representation, in the sense that basically the sparse matrix means a very few non-zero elements having at rest in the spaces are having non-zero values, which are basically useless for us to enter in a matrix. So to efficiently represent, we will consider all non-zero values along with the quotients in row-wise representation of a matrix. In a triplet representation of matrix, in the first value, we will store the row and the column, which is the location of the matrix. And in the third row, we are going to store the element, that is the data. For example, consider a matrix of size 5 into 6, containing 6 number of non-zero values. This matrix can be represented as shown in the figure. In this example, there are only 6 non-zero elements. Those are 9, 8, 4, 2, 5, and 2. And the matrix size is 5 cross 6. We represent this matrix as shown in the above image. Here, the first row in the right is filled with the values 5, 6, 6, which indicates that it is a sparse matrix with rows 5, 6 columns, and 6 non-zero values. The second row is filled with 0, 4, and 9, which indicates the non-zero value 9 is at the 0th row and 4th column in the sparse matrix. Similarly, remaining elements. And there is another method to store elements of sparse matrix, that is linked list. We are going to use a node of 4 spaces, in which the first two rows will store the location, i.e. the row of the element and the column of the element. And the third space will be occupied by the data, either it is an integer or some other data. And the fourth row will be pointing to the next element, so that we can traverse. This greatly reduces our time and storage complexity, because for for smaller values it may be easier for us to store in a matrix. But for larger values like a 100 into 100 matrix, if there are more number of zeros, it will be a waste of time and space. Hence, for example, if we have to search for a single element, we'll have to go through each and every element. And in the worst case scenario, that is the Bigot notation, we'll have to go through the whole matrix, that is n squared times we'll have to run the loop. to get to the element. But if it is in the case of a sparse matrix, we'll get there in maximum n number of times, where n is the uh, number of non-zero elements. So this is much better way to store data. Hence, sparse matrix help us to make the and store data faster and do things faster. Thank you.